So now that we know that in UCS Manager version 1.4 there is support for fabric failover in hypervisor environments. We saw that on the previous slide with Hyper-V. So what about VMware, and what about an installation where you have VMware running the vSwitch or the Nexus 1000V? Can you use fabric failover in this scenario as well? Well, you certainly could, but does that mean you should? Well, maybe, maybe not. Let's take a look at this a little bit closer. So you can enable fabric failover, and just like we saw with Hyper-V, all of the MAC addresses for the VMs will be learned on Fabric A. We'll have fabric failover enabled. Those will be ready on Fabric B, ready to be pinned on a new uplink in the case of a failure event. However, remember with Hyper-V that high availability was missing from the onset. But that's never been the case with VMware. VMware, you've always had the capability of defining multiple NICs and providing load sharing across multiple NICs and high availability across multiple NICs. If one of the NICs were to fail or the cable were to fail, the VMware hypervisor would be able to provide that failover capability from one NIC to the other. So what value does fabric failover really bring to that design? If you're typically going to define multiple NICs in your VMware environment and configuring things like load sharing and high availability, fabric failover really doesn't bring much to the table other than potentially complicating things a little bit further. So if you're going to have a design with multiple NICs on your VMware host running vSwitch or 1000V, you're probably better off just letting the VMware vSwitch or the Nexus 1000V handle NIC failures and load sharing as you normally would do. However, there might be one use case of a single vNIC design option, and this is probably not something many folks would implement, but there might be some. And the idea here is that you would just provision a single adapter on a VMware server, and that single adapter would be providing redundancy through fabric failover. And the idea would be to simplify the VMware design and configuration. So you've got redundancy with one NIC, something that's never been possible before with the VMware. You also have deterministic forwarding. We know that because there's only one NIC on this server and it's going to one switch, we know that everything coming out of the server is going to this switch. There's no troubleshooting or trying to figure out, where's traffic going out of which NIC and on which switch. It's all going to 6100A. Unless there's a failure, it'll all go to 6100B. So there is some deterministic behavior to that may or may not be helpful in troubleshooting scenarios. But on the downside, you have no load sharing here. All of the traffic from this server is using 6100A and not at all using 6100B, even though we might have two 10 gig paths available out of this physical adapter. We're really only using one of them, and only one fabric is used. So in this sense here, it may not be the best option to use fabric failover with VMware when you're running the vSwitch or 1000V. You're probably better off just allowing the virtual switch environment down here with multiple adapters to manage the high availability and the load sharing in that environment. Unless this type of design is appealing to you, a single vNIC design with high availability, then you may want to entertain this thought. Okay, we are on the topic of fabric failover, but I'm going to take a little tangent here, and we're going to talk about, okay, if fabric failover is not the best choice for a VMware host running the Nexus 1000V, what is the best practice design for implementing the Nexus 1000V with VMware on UCS? Because we mentioned on the previous slide that it may not be the best choice. So here we're going to take a look at what our basic recommended design, best practice design is for the 1000V on UCS. And this has been documented in a pretty extensive white paper that's been published on Cisco.com. So the link is there. I encourage you to read that paper. And this is a brief summary of that white paper. And basically what it discusses is provisioning two vNICs to the VMware server, vNIC 1, vNIC 2, and showing those to the Nexus 1000V as uplinks. So the Nexus 1000V will see in this case here Ethernet 1.1, Ethernet 1.2. And we'll define a single uplink port profile, and here we've called that, I'm just calling it here uplink. And we're going to define the forwarding mode as MAC pinning for the Nexus 1000V to use for these two uplinks. And same thing down here, where we'll define port profiles for the VMware machines. I've got one here called data. I might have another one here called management. Now, in a lot of cases, customers want to separate the virtual machine data traffic from the management traffic, the service console or the VM kernel traffic. And we can accomplish that with MAC pinning. So I defined MAC pinning on my uplink port profile here. I've got subgroup that I've defined on the uplinks on Nexus 1000V, Ethernet 1, 1, and 1, 2. So I said subgroup 0 here on Ethernet 1, 1, and I went to Ethernet 1, 2, and I said subgroup 1. Now if I want the VM data to use this path over here to 6100A, while the management traffic uses a separate path over to 6100B, I can influence that through pinning. So in my port profile for the VM traffic, port profile data, I entered a configuration line that said pinning ID 0. And pinning ID 0 corresponds to subgroup 0. Same thing here with the management traffic. Pinning ID 1, that corresponds to subgroup 1. And what I've done here is I've able to steer the traffic from virtual machines away from management traffic as a primary path. And of course, if there is a failure of one link, then they will be joined on the same link together on the same fabric. But here I've provided a pretty simplistic design of just two VNICs, and we've provided segregation between virtual machines and management traffic. You can do this for other types of traffic as well through defining subgroups, defining pinning IDs, and using MAC pinning as the forwarding mode, as the recommended forwarding mode for Nexus 1000V when you're attaching to UCS. Alright, let's get back to Fabric Failover and implementations with VMware. So I mentioned a couple of slides back that using Fabric Failover with VMware vSwitches and Nexus 1000V may not be the best thing to do. But there is a case with VMware implementations where Fabric Failover absolutely is a slam dunk. In fact, it's enabled and on by default when you do it this way. And this implementation is with VMFX, or has otherwise been called in the past hardware VNLink. And this is where what you're really doing is you're providing a pass-through, hypervisor pass-through switching on the VMware host from the virtual machine, passing through the hypervisor, and the virtual machine is logically connected with a virtual cable all the way up to the 6100, just like we've been discussing thus far with physical servers and their virtual adapters. So what we're able to provide here is a VM with a single software virtual NIC using the VMXNet3 driver, but it's bypassing the hypervisor and logically connected to its own virtual Ethernet port up here in the 6100A. So you're getting the benefits of all of the VMs connected logically to the same location as all the other servers, getting a more consistent management of servers, be it physical or virtual, in terms of their network connectivity and policies and settings. And you're also providing that hypervisor pass-through capability with a single virtual NIC on the VM without having to, and providing redundancy without having to provide multiple software virtual NICs in the VM. So in this case, when you enable VMFX with Cisco UCS with VMware, Fabric Failover is on by default because providing the high availability that would otherwise make this a very complicated solution. If you did not have Fabric Failover here, you would need to have two software VMXNet3 NIC drivers on the VM, one passing through to one NIC and one passing through to the other NIC, and that would become a very cumbersome and complex solution. But because Fabric Failover is there, you have the benefits of hypervisor pass-through, and you are not changing the way that the VM is configured at all. It still has its single software NIC that it sees. You don't have to make any changes or complicate the way that you do, complicate the way that you configure your VMs. And you have some load sharing here as well. When you have multiple VMs on a server, the VMFX is basically going to round robin across one fabric to the other in terms of which VM is using which fabric. So I've got VM 1 and 2 here. One's going to be using fabric A, one's going to be using fabric B. That was basically just a round robin decision made by the Fabric Interconnect or UCS Manager to do that. There are other settings where you could weight everything over to one fabric and just use the other as standby, but the default is for Fabric Failover to be enabled. In fact, you can't disable it, and the load sharing is provided in a round-robin fashion. So this is definitely a slam dunk for Fabric Failover with VMware. Is the hypervisor pass-through, and even moving into the future, how this solution will evolve is a complete hypervisor bypass, where you'll still have the same VMXNet 3 driver on the VM, but it will completely bypass the hypervisor and land into the UCS virtual infrastructure of virtual cables and connected directly to the 6100A or B. So that is Fabric Failover with VMware, and this has been possible since UCS Manager version 1.1.